For this video, we are going to place here the definition for the Dirac's measure. The Dirac's measure is of course a measure, and it satisfies both conditions for a certain function to be called a measure function. Previously, we also illustrated and proven the counting measure. So for this, in the next video, we're also going to prove that the Dirac's measure is a measure. So here comes its definition. Let x be non-empty, okay, and let's say script m is equal to a power set of set x, okay. Let us fix x sub o, the element of x, and define the function, okay. In this case, let us define it mu as well, mu with mapping of your script of m towards this, as this is the definition or part of a definition of the measure function. But for the definition of Dirac's measure, it would be in this form: mu of e, where of course e could be a subset, okay, of x, right? So this is how it is defined using this piecewise function. You will get 1 if your x sub o being element of x is also an element of e, and 0 if x sub o is not an element of e. Okay, then mu is a measure. Of course, we're going to guarantee this on a proving or a proof over this in the next video. Okay, and then this is called the Dirac's measure. So basically, for this measure, we simply need to identify whether the given x sub o, which is an element of x, is also an element of, it's a subset of x which is e, and if it's not, you will get here two results only, 0 and 1. Of course, let's illustrate it here. Let's say, let's have this finite set of x. You have 1, 2, 3, 4, and 5. And let us say our e sub 1 is a set containing 2, 4, 5. E sub 2 is, let's say, 1, 3, and 5. And let's fix x sub o. Let's say, for example, it is 4. So for this measure, if we are going to get the measure of your e sub 1, okay, where we again fix x sub o being 4. Since 4 is an element of e sub 1, and it's given by definition, if it's an element, the result here is 1. For our mu of e sub 2, okay, take note that our x sub o is still 4. And since 4 is not an element of e sub 2, based on the definition, you will get here 0. So again, it's just 1 or 0 for a Dirac's measure. We are going to prove this measure to show that this definition is really a measure on the next video. So for this, this is just the definition and a short illustration. Thank you very much for watching.